Okay, next we're going to talk about the cover-up method, which is a shortcut for finding unknowns in a partial fraction decomposition in some special cases. So we usually don't teach this in Math 141 because you're busy learning how the partial fraction decomposition works in general. And usually we want people to have that down solid before we add techniques that only work in special cases. Okay. So the idea is we're starting with this sort of rational expression P of S over Q of S. And we're going to have some factor S minus A that is non-repeated. So it only shows up once and it needs to be linear. So we know that because it's only showing up once, the format of this term in the partial fraction decomposition is going to be some unknown over S minus A. And so this is a formula for finding that unknown A. That A we're going to get by evaluating our original rational expression, where we're going to just imagine covering up, just ignoring the S minus A term. And we're going to evaluate A at the numerator over, well, everything else that was left over that didn't include S minus A. We're going to plug in this 0, S equals A. And so what that gives us here is the numerator evaluated at A, that's 0, over the denominator except for S minus A, evaluated at A. All right, so let's do just a couple of examples of this. Okay, so for example, if we have an expression like 5 minus 2s over s plus 3 times s minus 1, our partial fraction decomposition has just two terms in it, one for the s plus 3 term and one for the s minus 1 term. Notice that each of these factors is in the denominator is not repeated, so this method applies. So this is saying that to find A, what we're going to do is, so we see the 0 of that denominator. So we're going to be evaluating where s equals -3. We are going to cover up the s plus 3 term and look at everything else, 5 minus 2s over s minus 1. And we're going to plug in s equals -3. So 5 minus 2 times -3 over -3 minus 1. So in this case, we have 11 over 4. All right, to find B, first, let's look at the denominator here. We're going to be evaluating when s equals 1. We're going to cover up this s minus 1 term. Everything that's left over, we have our numerator over s plus 3. And everywhere we see an s, we're plugging in 1. So we have 5 minus 2 over 1 plus 3. And so this gives us 3/4. And so, most importantly, with very little space, we are able to write down our partial fraction decomposition. Okay. All right, so let's try this out with another example. Here we have a fully factored denominator. We've written out the format of the partial fraction decomposition. So each term in this denominator is a linear term. So it just has constants on top. So A, B, and C, we're looking to find them. We can use this cover-up method. So we're going to think about what makes the denominator of the A term equal to 0. And so that's going to be x equals 0. Then we're going to cover up with your finger this this term that goes to 0, and then we're going to be evaluating everything that's left over at x equals 0. You don't need to write this out each time. I'm just trying to write it out a little bit more here while we're getting the feel for this. Okay, so every place we see an x, we're going to evaluate at 0. And so this gives us 2 over -2, or -1. Okay. Next up, we're going to look at the b term. So think about where that denominator is equal to 0. That's going to be at -1. Okay, so we're going to cover up the x plus 1 term. We're evaluating everything else. Or like we're considering everything else. And we're going to evaluate where x equals -1. So we have 3 times -1 plus 2 over -1 times -1 minus 2. Okay. So this gives us -1 over -1 times -3. So 3. Okay. So b is -1/3. And then finally we have this c term. Okay. So we are going to be looking first at where the denominator is equal to 0. So that's at x equals 2. We're going to cover up the x minus 2 term and everything else. We're going to be plugging in x equals 2. So this gives us 6 plus 2 over 2 times 3, or 8/6, or 4/3. Okay. And so putting everything together, we have -1 over x minus 1/3 times 1 over x plus 1 plus 4/3 times 1 over x minus 2. All right, great.